Hello, sir. Welcome to our presentation for Mathematics 1. Our topic is Uses of Mathematics in Real Life and in CSE. My name is Orgodev Shikdar, ID 252-15613. Our team members are Biprojit Dotto, ID 252-15521, MST Sabrin Sultana Meep, ID 073, MD Sabbir Bhushan Setu, ID 574, MD Asif Rahman, ID 204, Sadia Jahan Mahira, ID 243, Abu Bakr Siddiq Prottoy, ID 290. Now let's start our presentation. My name is Orvodev Shikar, ID 613. Today I will talk about how mathematics is used in robotics, a field where computer science and real-life application come together. Robotics is all about designing, programming, and controlling machines that can move, sense, and make predictions. Behind every robot, whether it's an industrial arm in factory or smart robot vacuum at home, there is mathematics. First, geometry and trigonometry help robots understand their position and orientation. For an example, when a robot arm needs to pick up an object, it calculates angle and distance using those branches of math. Then comes linear algebra. It's used to model how a robot moves in space, especially for robots with joints, wheels, and multiple legs. Matrix and vector are used to control direction, rotation, and movement. Calculus is another essential tool for robotics because robotics often need curves and need to adjust the speed. Calculus is analyze those motion and change over time. Probability and statistics help robot deal with uncertainty. For an example, when robot is navigating using sensor, it uses algorithm-based probability like SLAM to map out the environment and avoid obstacles. Finally, in computer science, those mathematical concepts are implemented using algorithm and code. Robotics combines CSE and mathematics to bring intelligent machines to life. In short, without mathematics, robot couldn't think, move, or adapt. It's an invisible power behind every robot in action. Thank you very much.
Thank you, Orgo. My name is Biprojit Dotto and my ID is 252-15521. Now I will talk about some real-life application of vector and I will also explain the breakdown of how vectors are used in both CSE and in real-life contexts. Application of vectors in real life. There are many uses of vectors in real life such as navigation and direction, sports and physics, engineering and construction, and also animation and gaming. Now I will explain all of them. Navigation and direction. In real life, airplanes, ships, and cars are used vectors to determine direction and speed. Also, GPS system calculate routes using vectors-based movement. Sports and physics. In football, cricket, or basketball, players and balls move with velocity and direction. And also forces like gravity, tension, thrust are vector quantities. Engineering and construction. Vectors help in analyzing forces on buildings, bridges, and other structures. Animation and gaming. Character movement, object trajectories, and collision directions use vector calculations. Now I will explain the application of vectors in computer science and engineering. There are many uses of vectors in CSE like computer graphics and animation, machine learning and data science, robotics and AI. Computer graphics and animation. Vectors are used to represent shapes, movements, rotations, and scaling. 3D models and scenes use vector mathematics for rendering. Machine learning and data science. Data is often represented as vectors. Algorithms like KAN, SVM, and neural networks operate using vector math. Robotics and AI. Robots use vectors for path planning, positioning, and motion control. That's for me. Thank you for watching my presentation.
Thank you, Biprojit. I am Sabbir Sultana Meem. My ID is 252-15073. Today we will be presenting on uses of mathematics in real life and in computer science and engineering. In this presentation, I will begin with my topic time management. We all know that time is a valuable, but what truly makes a difference is how wisely we manage it. In both our personal lives and field of CSE, mathematics plays a key role in helping us make the best use of our time, logically, efficiently, and smartly. Let's explore how math supports time management in both worlds. Scheduling algorithms in operating systems. In in computer science, the operating system uses mathematical logic to manage time between tasks through scheduling algorithms like fast, come fast, sort, for round and robin. It ensures that every task gets CPU time efficiently, just like a smart timetable for a busy student. Optimizing code execution time, programmers use math measure how long a piece of code takes to run. Concept like time optimization helps us write faster, more efficient programmers, saving time for both user and system. Planning daily is effective efficiency everyday life. We use math without even noticing. From estimating how long each task will take to organizing study hours or meetings. Math helps us plan better and avoid wasting time. Managing deadlines and productivity mathematical tools help track our progress, set priorities, and meet deadlines. Whether it's creating to-do list or dividing time across subjects, a logical number-based approach if increase productivity and reduce stress. In conclusion, mathematics is not just about numbers. It's school that helps us manage our time smartly both in personal life and the incomprehensible system. By applying mathematical techniques, we can improve efficiently, reduce stress, and achieve our goals faster. Thank you so much.
Thank you, Min. Assalamu alaikum. I am Saprashan Shetty. My ID is 2521557 Today, I will be talking about how mathematics plays a circle role in real life, especially in the world of banking and finance. Let's begin with cryptography. Every time we make an online transaction, mathematics protect our data. Cryptography, which is based on complex mathematical formulas and number theory, ensure that our for personal and financial information is secure and encrypted, preventing unauthorized access. Next is bank use mathematical algorithms to automatically detect unusual activity in customer accounts. For example, if a transaction does not match our spending pattern, the system may flag it for review. Those smart algorithms use static, probability, and machine learning, all rooted in math, to fight financial fraud. Thirdly, we have bookkeeping and financial planning. Individual and business rely on basic arithmetic and percentage calculation to plan their monthly and yearly budgets. Whether it's controlling expenses, tracking income, or saving for future goal, math helps people make smart financial decisions. Finally, let's talk about interest, EMI, and savings calculation. Mathematics helps us understand how much interest we earn on savings or how much we need to repay as EMI on loans. Smart interest and compound interest formulas are used every day by banking and customers. Those calculations are important for everything, for credit card to fixed deposit. In conclusion, for ensuring digital security to make smart money choice, math is everywhere in banking and finance. It is not just about number. It's about making life safer and easier. Thank you.
Thank you, Sabir. Assalamu alaikum. My name is Asif Burman and my ID is 252-15204. Today I will present about game development in CSE and real life. Game development means creating game using program design and creativity. It is not just about playing game, but about learning how games are made, how graphics are created, and how character work inside game. In computer science and engineering, game development is a practical way to learn coding. We use programming a language like C++, Python, and C for developing games, and game engine like Unity and Unreal Engine to design game environment. It is help us understand algorithm, data structure, and artificial intelligence while creating games. We also mathematics for graphics and physics to uh, make the game movement realistic. This help us to build logical thinking and problem solving skill while working on fun project. In real life, game development also has many benefit. It move our creativity and teamwork and planning skill because we need to design store character and list while working with other. Game development is also used in education and training simulation like medical and military training, and even in flight simulation to practice skills safely before applied them in real simulation. It is also help us learn to manage time and complete project within deadlines. Learning games development has many advantages. It improve our coding skill, teach us teamwork, build our logical thinking, and prepare us to future career in gaming industry, which is growing rapidly worldwide. It is also make learning programming enjoyable, and we can showcase our skill though game project and uh, during university or job placement. In conclusion, game development connect computer science knowledge with practical life skill. It is a creative and exciting way to learn, program, and prepare for future opportunities while developing ourselves in a fun and effective way. Thank you so much for listening to my presentation.
Thank you, Asif. Hi, I'm Sadia Jarma here. My ID is 252-15243. Today I'll be talking about how mathematics plays an important role in real life through machine learning, one of the most exciting fields in computer science. At its core, machine learning is built on mathematics. To measure branches, linear algebra and calculus are the essentials. Linear algebra helps machine process and represent data using vectors and matrices, while calculus allows algorithm to optimize learning by minimizing errors step by step. We also use statistics to make decisions. In real life, that's how a system learns from past data, identifying trends, probabilities, and making prediction. This is why machine learning models improve over the time with more data they get. These mathematical tools are not just theories, they power things we use every day. For example, voice assistants like Siri and Google Assistant understand speech and respond using models based on math. Even YouTube and Netflix use machine learning and therefore math to recommend videos based on what you have previously watched. So in computer science, math isn't just a subject. It's the engine that drives intelligent systems and gives us the logic and tools to solve complex problems and build smarter technologies. Whether it's helping doctors detect diseases earlier or making self-driving cars smarter, math in machine learning is changing how we live, work, and connect. It's not just solving equations, it's about solving real-world problems in a smarter way. Thank you.
Thank you, Mahira. My name is Awokose Diprattar and my ID is 252-15290. Today I am going to talk about how mathematics is used in athletics and why design meets engineering and creativity meets precision. Architecture is not just about how building looks, it's about how they stand, how they function, and how they last. At all the heart of all that is mathematics. To begin with, architecture used CNE software, computer-aided design, which relies heavily on geometry and modeling. CAD helps create accurate design, blueprints of building, bridges, or even smart cities using exact angle, measurement, and shapes. Next is parametric design, where architecture use algorithm to create flexible and smart structure by adjusting just a few numbers like height, width, and curves. The entire design automatically update. This makes the design process both creative and efficient. Mathematics also ensured the balance and structure of building. Engineers calculate load, force, and pressure using formulas to make sure the building can handle real-world conditions like earthquakes, wind, and wake. Finally, mathematics plays a huge role of the visual beauty of architecture. By using angle, proportion, and symmetry, architecture creates space that are not only strong but also visually pleasing. In computer science, concepts are supported by simulation tools and modeling software, making architecture design smarter and faster. So, in short, mathematics is the backbone of modern architecture. Without it, we could not create the safe, stunning, and smart structure we see around us today. Thank you.